Wow, we got good attendance on that.
Yeah, some of the big data. No, they have like this. Big data.
For our special computational research in Boston seminar. And I guess a lot of you heard about this on the big data processing. Is that an MIT email list or is that a local?
It's a meetup.
It's a meetup? Okay. Wow, the power of social media. This actually continues a bit of a tradition. We normally don't have July and August seminars, but when we do, we always think they're going to be incredibly poorly attended, and they're always very, very well attended. I don't know why, but I guess a lot of you should be taking more vacation than you are. So, Nob is going to tell us about
it's good to see you again.
Nice
seeing you. How are you? Good. How are you? Thanks.
So I will turn over to
See you.
Hello everyone. Yeah, thanks. So thank you for all of you for having me here. My name is Nobuaki Tounaka from Japan. My name is rather long, so just call me Nob. Not Bob. No. I am the founder of Universal Shell Programming Laboratory Limited. The reason I have come all the way from Tokyo is CEO and introduce the new software development method, the Unicage and Unicage Data Analytics tool. I hope you find it is useful for you. And I, in Japan, work surrounded by Japanese enterprises, and the members of enterprise of Japan saying always, oh, there's many problems in computer system. Isn't there a more speedy computation method for my complicated calculation? Or, yes, there is, but too much to run the programming. And, or, let's use this one, but very expensive or big iron and so on. Yeah. And for this problem, Unicage might be the answer. So I will explain about the Unicage. Okay. Yes, and this is the menu content. I will explain from now. My presentation has 3 sections: a Unicage introduction and Unicage cluster, BOA, big data oriented architecture, and 3, a live demo. And Unicage itself, it's not a package. Unicage itself is a method of utilize the Unix fundamentals and plain text file as a database. We do not any relational databases, and we only use flat text files only. And we write application only using the shell script, not using Java or any other language. We only use shell script to build up the system. It is not a software package. For hardware infrastructure, it requires only a machine running a Unix-like OS. And based on the Unicage method, the Unicage framework consists of 3 main factors. The first factor is data analytics tool and command set. And most of the tools are developed in C language or assembler. And the command is designed to work efficiently with one another through the shell pipe. Each command is connected with pipes. So it is designed as a filter. The command design is Unix-oriented, which means simple is best and do one job well. Yeah, we are dedicated to the Unix philosophy. And second one is text data management, which is a technique to organize data. As I said, we do not use any databases, so we have to arrange or organize data in advance. In Unicage, data is arranged 5 layers, and we strongly recommended the end user's involvement, especially level 3 data structure. Yeah, I will talk about the text data management afterwards. And the third factor is standardization, standard of shell programming, which is a basic shell programming rule that we recommend. Well, shell programming is easy, you know, but it does not mean anyone can do simple and efficient programming. That's why we say standard. Yeah, standard is necessary for shell programming, I think. Keep the program as short as possible and design software functions independently to allow system flexibility. Yeah. And next. Well, if you would like to do some data analysis, Unicage tool is very useful. But however, to build up data analysis, to build up data analytics software or system, you need to understand the basic architecture of Unicage. These are 3 parts of Unicage software architecture forming the data cycle. The Unicage may be the data-oriented method architecture. And input script is for interface part, which raw data is received. And create shell script is for a part of where data is organized for application. And the application part is output script. And every shell script is categorized into 3 types of shell script. Okay. And so back to the data organization. We are in the level from 1 to 3. Data is organized, corrected, and stored completely. Completely independently from the application. Yeah. And in level 4, data is specifically arranged for each application. And level 5 data is output data from each application. For example, logs or data for other systems and so on. And level 1 data is a raw data, and it is the most important data, and the data cannot be lost and stored permanently. Well, this may seem like the amount of data grows as it is being created. Yeah, and we store any type of data permanently. So that means it requires much hard disk. And because the data is every time increasing, we never erase data. So, but thanks to the big data storage, I think storage doesn't matter anymore because the cost of hard disk goes down and down drastically in these days. So it does not matter to store data permanently. Okay. And now, at this point, you can almost make use of the Unicage framework. But one thing I'd like to explain is the Unicage mind or philosophy. It is a separation. It is a concept of separation. The data, program, and hardware is separated by business and organization and application. Yeah, I'm Japanese, and to say separate, to understand, is assigned by the same Japanese word, wakeru. Wakeru. Wakeru means divide and separate, and it means also understand. So for Japanese, to understand is to separate. So we arrange data separately. All data is separated according to the business and organization and so on. And this policy makes the total system simple and flexible, and it allows us to understand the system. But about sharing data, the principle of Unicage data management, we copy from original data to organize data. So in database, physically data exists only in one substance. But in Unicage, many data which has the same meaning. But we distinguish the original data and corrected data. Yeah. Okay. And in Unicage, development process is unique. And we have no any databases. So in the first step, and at the first step of development, at first, develop shell scripts for receiving and organizing data. Yeah, we create data in advance. And second step, we make an application. So of course, in the first stage, we write shell scripts for creating data, and the next step, the application is written by shell scripts. Also, both are written in shell scripts. And data creation is object to the rules of level management. And to understand the Unicage, let's do a simple demo from now on. Sorry. Can you see that? Okay. Yeah, I now log in the server in Japan. Yeah, from internet. And see the report. Yeah, it is a simple demo of making a report of sales report using Unicage. And all data is organized as a text file, and there are text files. And this is a transaction file, sales file, and the size of this data file is about 1 million byte, over 1 million byte. And let's see the head of the file. Yeah, and the data indicates from the left, 001, it's a shop code, and 007 is an item code, and this is the sales date and quantity, dollars, and discount. And how many records in this? Let's use line count command. It is one of the Unicage command. And about 3 million, over 3 million records. Yeah. And this is the transaction file. And next, in the, for example, the master file like net price, price file. Yeah. The price file.
So how is that line count command different than the normal line count? Because I missed that.
LCMT コマンドは普通の WC とどう違うんですか?
Yes. A WC command outputs an additional data what we don't use. For example, yeah. Oh. Oh. Internet. Oh, network is connected. Oh. Just wait. There you go. Okay.
動きました。Anyone downloading a movie over the guest network?
It is lunchtime.
Yes.
Oh, the network doesn't work.
The line count command that they created, it only outputs the number, and they do that so that they can use that output as that result in the program. So you don't get all the other details that come with a WC command. That's basically it.
The WC command outputs the number of lines and the number of words and total bytes and the name of the file. That's about the core information. What we want is the number of files, number of records only. So it is more useful than WC. And yeah. Wait. ちょっと繋がらない。繋がる。切れてしまいました。繋がらない。
It's not you.
切れてしまいました。Oh.
Looks like you're on the MIT network, not the MIT guest network.
Any guess?
Try switching to the guest.
Yeah, but.
Oh.
それならライアンの接続しますか。All right. Back up line.
Ah, でもこれは違う練習。あ、そうか、一回。
Sorry. It'll be a slower connection, but hopefully it'll be enough.
It just means the console access, right?
Yeah, we're not doing any major. Of course, you know, it is AT&T. Okay, we're back online.
Back to the presentation. Yes, this is the head of sales data. I explained the shop code, item code, date, quantity, and the data, and the discount. And another file is price file, and the net price and the standard sales price. It's the item code here. And the next file category. This is item code and the category code which belongs, which the item belongs to. And last file is a category name file, and the category code and the category name. And combining these 4 text files, let's make a sales report by using a Unicage command. And the first step is to join 2 files. And using the join 1 command, key equal 2. 2 is the position of connect column. And price and sales. And this is a Unicage command, and it's designed to output standard output and work 1. So another file output and the work file, and head work 1. And let's check the content of work 1 file. And yes, certainly the net price and the sales standard price is connected just after the item code. And the next, join 1 category. Oh, yes. Yes, and the category code is also connected, joined. And third step, using lcal command. Lcal command provides a calculation function. And it's like awk semantics, awk command semantics. It's right. It's right. Those 3. Third column means category, and 7th the quantity, 8 data, and 8 minus 4 by 7. And that means sales minus net price by quantity. So that means somehow profit. Yeah, lcal command supports a very precise floating number. And the float is 16 lengths of floating point. Yeah, and yeah, many zero. It means the very precise calculation of floating point. And let's sorting by the category code. And let's use msort command. Msort means merge sort algorithm. And key equal 1 means the first column, and work 3, output work 4. The total records is 3 million. Yeah. And msort provides a multi-process, multi-threading function. So if we indicate, add a -P8 option, the parallel 8 thread is parallel. So it goes faster than before. And let's check the output. And next, summarize group by category code. And sm2 command is a sum up command. And 1, 1, 2, 4 means from 1 to 1 columns is a key. And from 2nd to 4th is columns which must be summed up. Oh. Stop. Oh. Yeah, okay.
Just, it's a review.
Okay. Yeah. And this is the result of summarization. And next step is, yeah, it's this digit is rather large, so To make it simpler, use div_k command. Div_k means divided by 1 kilo, 1,000. Div_k. A second field and a third and fourth field. Yeah. And the next SM5 command, from 1 to 1 is a key field, and from 2 to 4 columns is a sum up command, sum up columns. Oh. And next, using the op command, let's calculate the ratio, percent of profit. Oh. Profit divided by total sales. Ooh. And the next step is to round up the floating point. Use roundup command, round command, and 1, 2, 3, 4, 5. Fifth field to round up one floating point. Yeah. And to join the name of category, use cjoin2 command. And to add the comma string, comma character by every 3 digits, use comma command, and 3, 4, 5 columns. Yeah, and to beautify, fixed code. Fixed codes and work to, oh, fixed codes. Yeah. F code.
F calls.
F code. Yeah.
It's a different name in Japanese.
Yeah.
He's getting used to the English version.
Yeah. Oh, so yeah. As Ryan said, as Jim said, the some of the commands are Japanese word. So for this presentation, we prepare our English word for a Japanese command, but just a symbolic link. Yeah, and this is how to make report. And let's show history. Yeah, these are the commands I input. So, and copy and paste to text file. That is a shell script. So, sample, yeah. This is a shell script. Every command I input just before. So, let's take a time, check the time, see the time. Yeah, about 4 seconds. 3 million records of transaction is summarized and made to a report. And this is the first step of Unicage. And it is easy to use each command, and the command line is very easy. There's a little option, few option, and the commands, the number of commands we frequently use is about 30 to 40. But we provide commands. The total number is about 160 or so. Yeah, and the next step is its shell script does the same things as the sample one, but each command is connected with pipe. There's no temporary file. Check, compare, sample, and yeah. The previous shell script uses a temporary file. Input file is a work, blah, 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 and output is work, blah, blah, blah. Yeah, but the second example is all command is connected. So according to the Unix fundamentals, each command runs or are executed at the same time on the parallel process. And the command itself, the pipe itself, is a memory about 4 kilobyte size. So that means on-memory parallel processing. So let's see the time. This is about 2.5 seconds. It's faster than before. And the total time of CPU time, 3.0 plus 0.8, is longer than 2.5. That means the parallel processing is effective. Okay. Yeah, that's a simple demo. Yeah, as I said, yeah, this is the all command set. It's a list of command set. And the draw line, duplicate, CSUM, and this is an English word, and the original name, Japanese name. So let's see, error command. Error command will just a symbolic link to Japanese word gyo. It's my pleasure to use this Japanese original command. So let's say gyo. no word count or no line count. Yeah. Yeah. Then next, back to the presentation sheet. Yeah. And as I explained, to get faster computation, utilize hardware resources more efficiently with shell pipes. Yeah, and from the kernel version 2.6 of Linux, each process is shared among each core according to the workload. And the pipe enables the parallel processing, so it works very fast, efficiently. Okay. So we need not any multi-thread programming. Just combine with pipe, we can easily utilize the power of multi-core. And to use the shell scripts, there may be many questions. Yeah, and it is a typical question and answer. Yeah, how to implement specific processes. Yeah, for example, how about exclusive lock, right? RDB. But every command is made from made by C language, and we wrap system calls, all system calls of Unix into a command in form of command. So we utilize every function of system calls. So the exclusive lock function is provided by OS by using flock system call or a symbolic link and so on. So we wrap the function of OS system code, and we made up command Europe and so on. And order control, commit. Oh, how about commit? And but commit, yeah. But we use normal file system. So make a decision based on a return value from OS system code, write system code. If write system code returns 0, return true, it is just committed. And how about rollback? And in database, the rollback function is important, but using Unicage, all files is processed from input files to another output file. So that means every history remains. Every history remains. So we go to the any point, wherever we like, And the parallel processing, yeah, of course, using a pipe or so, parallel processing is possible. But we provide a para and crust command series. And using these commands, it is very easy to utilize the parallel process. Yeah. And next. And next, let's move on to the next section. Unicage cluster, BOR, big data oriented architecture. Yeah, it is a command set, cluster and para command sets. Yes. BOR is a cluster computing appliance and dedicated to big data processing based on Unicage development methods. It is implemented in Unix OS with the original Unicage shell and Bubun file systems. Bubun file system is like is a kernel patch, and we customize a write or read system call. And the big file, for example, 10 gigabyte or so, can be seen as many of small files. So we customize OSs. Yeah, and yeah. And this is features of BOR. Yeah, OS space. Yeah, it is runs on now Linux and FreeBSD. And scale out type, like Hadoop. If you want to increase the power of the cluster, just what you do is to increase the number of slave servers only. And yes, of course, high-speed processing. And yeah, it works as usual servers, PC servers, so inexpensive hardware can be used in this BOR. And of course, we provide these products as a business, so maintenance support we provide. And stability. Yeah, there's a very simple structure based on Unix, so it is very stable. Yeah, here is the basic cluster configuration. Yeah, one master and several slave servers. And each server has been installed Unix and commands only. And the network between servers and clusters are the InfiniBand high-speed network. Yeah. And how it works is you will write shell scripts only in master server. Yeah, so if the server is heavy or it takes time to proceed data, what we have to do is to increase the number of slave servers, and this server is empty except OS and commands only, no settings. And when the big data is given to the master server, and the Bubun file system works and divided to many small files, and send to each small file to slave servers, and the shell script exists only in master server, and using cluster shell commands, the algorithm is sent to each slave server, and so that the slave server can execute shell scripts, and there is a data sent from the master. So the server, each slave server can calculate and return back to the master server, and editing something, and output the result. Yeah, this is the image of shell cluster. Shell cluster programming. Yeah.
Can you go back to the previous slide? Are you saying the slave machine has no connection with the file system, Bubun file system? Or
Yeah, Boolean files are only installed in this master file. It is a normal file system, ext3 or 4.
Okay.
No customization. There's only yeah, ordinary file system, and it works in a usual shell script, shell Unicage command only. Okay. And this is the image of shell script using Bohr. But the image of shell scripting is the same as normal shell scripting. Each command is connected with pipe. And only during big data, use crest command or para command or crest command. But if summarize the big data to somehow small data, and we can use a normal command. So this shell script provides a multi-core on memory and cluster we can utilize. And there is a very simple setting file in the cluster shell programming. This slave file, the name slave file is just only a setting file. The content of the slave file indicates the name of slave servers and the number of parallel processing only. Yeah, after that I show you. And this is a sample of the big data process. We have some case studies, and I'd like to share one of them. Yeah, it's about an analysis of search logs from a major Korean search engine. And an analysis based on text search, user IP address search, and the data size is about 5 billion records and 19.2 terabyte. Yeah, and we use shell script and level 4, and uses about 49 or so slave servers. And each server is a normal PC server, and Intel i7 processor, 16 gigabyte memory, and usual SATA disk, serial 88S. It's a normal servers. And the OS is, in this case, FreeBSD. And the homework came from Korea. And that is test SQL, sample. But we do not use any SQL. So if you write SQL, so we convert to shell programming from SQL, and see the process time. And for example, 03 before about 0.1 second or so, among the 19 terabytes. Yeah. And after that, I will show you some of the demo, which looks like this. And next, and live demo. This is the main part, my presentation. Yeah, and the first, human DNA quality check. The human DNA data is very large, and we process the DNA quality check. And second, real-time traffic processing. And the third, bank account deposit calculation, search in the world population by SQL-like shell programming. Yeah. And this is the Bohr configuration, 1 master and 5 slave servers. And every server has 2 CPU with 4 cores. And then the CPU model is Xeon E3 with 3.4 gigahertz. The memory is 32 gigabytes. Every server has the same specification, and connected with InfiniBand, high-speed connection. Yeah, and the first demo. the human DNA sequence quality check. Yes, we are collaborating on the genomics research with a professor from Tokyo University. And to be honest, I don't know much about the genomics, so never asks me about the genomics. I was taught the algorithm by the professor, and I implemented the algorithm on board. Okay. Yeah. So according to the professor, we are collaborating to build up a whole genome. For example, human genomes, you have a number of millions of DNA-based sequence that is produced from our DNA analysis machine. And in this sequence data, not all the base is precisely measured, but it's some uncertainty of correctness. So this is a series of base. The base consists of 4 characters, T or C or A or Z. But each base is not correctly measured by machine. So the uncertainty, the quality score, which those characters each represents the uncertainty of each base, and from this one quality score, and each character represents a quality check number from 0 to 40, and 40 is high and more precise, and 0 is very uncertain. And to have a base sequence of DNA with higher quality score, what we do is first calculate average quality score for every DNA sequence. And second, average quality score for every read with a quality condition on every DNA base. And the third one is the base which has the same position. Calculate the maximum and minimum and average and radium of each base output. We output, and according to the professor, using the PC, 8-core CPU, 19.7 GB memory, and the famous package software FastQC used, it takes about 40 minutes to calculate the average and maximum and minimum and radium of each base. And using Bohr, so let's return to the terminal. That's a human genome data. There are 24 files, and they are very, very big data. And the total size of the data, LLSQ5, SM2 command to summarize the number of size. So the total size is 34 GB. And let's see inside the genome data. Yeah, that's a human genome data. each DNA is shown in 4 records each. And let's select records from 34 gigabyte data. Food quality check average is more than 30. Okay. And let's CD and bore and shell. This is a shell script to calculate the quality check.
There's a question.
No, I'm saying you have about 3 minutes left.
And first, select records among the big data, which quality score is more than 30. And distribute POSIX file to threads. The big data you saw just before is distributed to 5 thread servers, and the 5 servers calculate quality check values at the same time. And the result, and the average value more than 30, we output result record, and about 18 seconds and more. Result. This is a result. And this is the average score, 37, 30, 30, and 31, and so on. And this is the human DNA. And next. And calculate each base, the quality's number. 11 seconds. We never skip any data. We calculate all the data, all the records. And in result 2, the genome base, which quality score under 30 is overwritten by dummy character X. And third one. Yeah, 4.8. It calculates in each file. There are 24 files, which shows different ranks of DNA, and calculating each file and the same position of genome, and calculate the quality check number of the base of the same position, and max and minimum and random and average. So you can see the tendency. The first part of genome, the score is high, 40, and so. But descending to the right side, the 40 score is low. So that is the quality of the reading machine. You can see. Yes. This is a genome model. Is anyone?
Quick question. If you had a data set that didn't fit in the memory of the slave nodes, would it still work? Would you just build a disk or?
There is a store, hard disk is stored, sent to the shared memory of slave servers. So the original data is stored on hard disk.
Yeah. So, but I mean, this data set was 32 gigs, and you had 96 gigs on the slaves of memory. I mean, would it work if you had a 200 gig data set?
のメモリの量以上にデータの量があればどうなりますか？
それは計算するのは難しいですね。
Slave lab, 足せば。
そうですね。
You just add the slaves, scale out.
It's assuming it's running.
So let's thank our speaker. Oh yeah, so by all means, just people can stay and answer or talk to you offline and stuff. I think if you want to send your slides to me, we can email them out to the group. Sure. Or you can just or a URL or something like that, or you guys see videotaped if you wanted to put the video up, just send me the information and we can get it out. So thank you very much. Thank you. No problem. I think